Hi guys, I'm looking at a couple of the questions that you guys put on the Google for over homework number 5 that you had. So one of those questions is number 10, and I think it might be just a calculator issue. So go ahead and have your calculator handy and I'll show you how to address this issue. So we were given a sub 6, and so I wrote the ordered pair for that. We're given a sub 1, and so I wrote the ordered pair for that, and we are told this is geometric. So I'm going to go ahead and just use that the first term is 144, and from there I know that a sub n will equal whatever term you're using, 144. I don't know r, that's what I'm trying to find, and since I used 144 and it's term 1, my exponent will be n minus 1. So I know another value for n. I can use 6, and I can use 645.700815. And so that'll now be to the 6 minus 1. Again, I'm trying to get r by itself. So the first thing I'm going to do is take in my calculator 645.700815 and divide it by 144. And it's ugly. Let me make sure I didn't miss any decimal places there. Okay, so now the question becomes that I need to get this root by itself. So if I want to get r by itself and I have an exponent of 5, I need to take the 5th root. So I had a couple questions on the Google form about how to do that in your calculator, and so I am again using the number that you see here. If you go to math and you go down to number 5, that's going to allow you to input whatever kind of root that you want. So again, that was math, and go down to number 5. And so now I can do the 5th root, and I want the answer in the step before, so I'm going to hit, let me move this so you can see it, I'm going to hit second answer. That gets the answer in the step before. And so here r is 1.35. As I'm looking at the next problem that you asked about, number 22, I know that 1 is 40 and 4 is 0.04. Okay, so that was given to me in problem number 22. Once again, it told me that it was geometric, so I can actually work this problem like the problem up above. So I know for geometrics, the explicit formula, a sub n will equal, and I'm going to use 40 times r to the n minus 1, and again I'm using n minus 1 because of this. By the way, I could say a sub n equals 0.04 times r, and the formula would be raised to the n minus 4. So I could use either one, it makes no difference. I'm trying to solve for r, so I'm going to plug in my a sub n that I'm given, and then r to the 4 minus 1. And so I'm going to use my calculator here, 0.04 divided by 40. And 0.001, that's 1 over 1,000 equals r cubed. So to solve this equation, I need to take the cubed root of both sides. Now, you could do this one without a calculator. The cubed root of 1 is 1. The cubed root of 1,000 is 10. And so there's r. But as a reminder, okay, math, and then hit number 5. So you got a glare. Let me try to fix that. There we go. And it allows me to take any root that I want. That's called an index, by the way. Okay, next let's take a look at problem number 1. I will tell you that as I read this problem, I actually did not even end up using an equation for it. You can. But I kind of drew this out. So we're starting with 5,000 insects. This is like week 0. So every 2 weeks, it's 1.2 times. So this slot is going to represent 2 weeks. This slot would represent 4 weeks. This would represent 6, and this would represent 8. Now, I certainly could use a formula here. Notice I'm actually finding the 1, 2, 3, 4, 5th term. But, I mean, it's pretty easy here to just take and just as quick 5,000 and multiply it by 1.2. And then multiply by 1.2. And then multiply by 1.2. And then multiply by 1.2. So sometimes, you know, these application problems doesn't necessarily mean that you have to have a formula. A lot of you guys actually asked about number 4 a little bit, and once again, I'm kind of going to start with drawing this out. So it says a ball is dropped 128 feet. It rebounds half the height. So 128 divided by 2 is 64. The next rebound is 32. The next rebound would be 16, 8, and so on. Now, if you want to find out about the 9th rebound, you certainly could do that. But here's the tricky part. 128 is not the first rebound. The first rebound is actually 64. Okay? So you have to consider that. If you were to use 128, which term would the 9th rebound be? Okay, and if you need to, you can certainly draw this out. Rebound 1, 2, 3, 4, 5, 6, 7, 8, rebound 9. So if you use 128, you'll need to find the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10th term. Okay, or you could use 64 as term 1. I mean, that is the first rebound. So if you use 64 as the first term, you are going to be finding term 9. Okay, either way, you're going to get the same answer. And so the answer that you end up with here is 0.25 feet. Someone asked about number 3, so let's look at it really quickly. So which term is 245? So that's wanting to know what is in, let me erase that real quick, for 245. So there's several different ways that we can do this. One way is we can go ahead and write point slope. So I see this has a common difference of 6, and I have the point 1, negative 1. So a sub n plus 1 will equal 6 times n minus 1. I know a sub n is 245. So I can just solve this equation. So I get 246 plus, or equals, 6 times n minus 1. 246 divided by 6 is 41, so n is 42. Here's another way that you can do that. You know the slope or the rate of change. You know a point, and you almost know another point. You're trying to solve for n. So I can use the fact that 6 is the slope, and slope is change in y over change in x. So, I mean, I could also solve this by using slope or rate of change. So if I multiply to get rid of my fraction, I get 6 times n minus 1 equals 246. Actually, notice I get the same equation that I did earlier. So it's another strategy on that problem.